In 1946, a sphere of plutonium and gallium weighing 6.2 kg and 89 mm in radius at the Los Alamos laboratory was sent to be melted down after killing 2 physicists who were studying it in an attempt to better understand how this sphere behaved in certain experiments that were being conducted. This sphere became known as the Demon Core, and this is the true story. What many people know is that 2 atomic bombs dropped by the United States fell on the cities of Hiroshima and Nagasaki in 1945, killing more than 200,000 people. These bombs were Little Boy, weighing 4 tons, which used uranium as fuel, and Fat Man, weighing 4.6 tons, which used plutonium as fuel. But what few people know is that a third bomb identical to Fat Man, called Rufus, was being prepared for later use. However, the attack with Rufus never happened because Japan surrendered. So the plutonium core of Rufus was returned to the Los Alamos laboratory, and several physicists began to study it and conduct experiments to better understand how the core behaved. The 2 cores of both the Little Boy and Fat Man bombs that obliterated the cities of Hiroshima and Nagasaki were light and could fit in the palm of your hand. But because they were very dangerous radioactive elements, they were transported in special meshes made of magnesium to dissipate heat and not reflect neutrons. With the core inside the case could fall and nothing would happen. Some physicists reported that these cores were warm to the touch. Just like several radioactive elements in nature, such as uranium and plutonium, when left alone without anyone doing anything with them, they are not dangerous. That's because the mass of these elements is not in a critical state. In simple terms, the critical mass of a fissionable element is the minimum amount needed to sustain a self-sustaining chain reaction. The core of an atomic bomb, when left alone, is in a subcritical state, a stable state in which it does not release radiation or energy into the environment. Its chain reactions are in a kind of equilibrium. That's why nuclear weapons, as well as their cores, can be exposed and close to scientists without danger. But when the core becomes critical, or even supercritical, the chain reactions of the radioactive elements inside the core start to happen uncontrollably. And then there's a lot of radiation and energy released into the environment. And that's exactly what happens in a nuclear explosion. Uncontrollable chain reactions are causing a massive cataclysmic release of energy and radiation. One piece of information that wasn't given is that these nuclei are constantly emitting neutrons in a natural and normal process known as radioactive decay. But if these neutrons, which are constantly being released into the environment, are reflected back to the core using some kind of neutron reflecting material, the core can become critical or even supercritical. And that's exactly what the 24-year-old physicist Harry Daghlian, as well as other physicists, were studying and conducting experiments on. To better understand, they wanted to see how close they could get to criticality using materials that reflect neutrons back to the core, but without letting the core become critical and without exceeding safety limits. On August 21, 1945, the physicist Harry Daghlian was conducting a critical mass experiment with the Rufus core, using tungsten carbide blocks around the core to see how many blocks are needed and in which orientation. The blocks reflected more neutrons back to the core, to the point of making it critical. Using a type of Geiger counter to measure the radiation emitted by the core, Harry Daghlian could tell whether the core was very close or not to becoming critical. And he got very close to making it critical, so much so that he decided to stop the experiment that day. But Daghlian was curious, and at the end of the day, he decided to return to the room alone to continue the experiment. Just like in the previous experiment, Daghlian arranged the tungsten carbide blocks in a way that made the core get very close to becoming critical. As soon as he added another block, his Geiger counter indicated that the core would become critical if he continued with the arrangement. Then Daghlian began to carefully remove the block, but he accidentally dropped it onto the core. The moment the block fell, the core instantly became supercritical, and according to Daghlian himself, a blue light instantly appeared, accompanied by a wave of heat. Immediately, Harry Daghlian reacted and used his right hand to remove the block that had fallen to the floor. In that split second when the light appeared, the physicist was exposed to a lethal dose of radiation. In fact, in that split second, Harry Daghlian received what was considered the highest dose of radiation a human being has ever received in history. A few days later, Daghlian was hospitalized. He showed strong symptoms of high radiation exposure, including nausea and pain. And 25 days later, he passed away due to multiple organ failure. He was only 24 years old. And this photo, taken when he was still hospitalized, shows the condition of the hand he used to remove the block. Daghlian wasn't alone when the experiment went wrong and he was injured. A guard named Robert Hemmerly was in a nearby room, sitting and reading his newspaper. Hemmerly died 33 years after that accident, after developing leukemia. Physicist Richard Feynman himself used to say that performing these experiments with the demon core was like tickling the tail of a sleeping dragon. However, experiments with the demon core continued, and exactly 7 months after Daghlian's death, another physicist would be involved in a very similar accident. In 1946, the physicist Louis Slotin, 35 years old, took control of the experiments involving criticality in a new laboratory. But Slotin was not very happy with his participation in those projects and the research that was being conducted. What he really wanted was to go back to teaching and conducting research in the fields of biophysics and radiobiology at the University of Chicago. However, he could not abandon the experiments involving criticality, because as he himself admitted, he was the greatest expert in experiments on criticality, and he needed to teach other physicists who would continue the research and experiments. On May 21, 1946, Louis Slotin was going to demonstrate an experiment to the physicist Alvin Graves and a group of 7 physicists. The experiment was similar to the one that Harry Daghlian was conducting. However, instead of using tungsten carbide blocks, he used 2 rough beryllium hemispheres, which served the same purpose as the tungsten blocks. These spheres reflected the neutrons back to the core. The hemispheres could never be completely closed over the core under any circumstances, because then the neutron reflection would be total. To prevent that, 2 small blocks were placed at the ends to keep it from closing. Slotin ignored the 2 small blocks and personally preferred to use the tip of a screwdriver to keep the hemispheres from closing completely, because that way he could get closer to criticality. And he did this dozens of times without any problems. The physicist Enrico Fermi told Slotin that he would be dead within a year if he kept doing the experiments using a screwdriver. At 3:20 that afternoon, while the experiment was underway, somehow the screwdriver slipped and the hemispheres closed completely over the core. Immediately, an increasingly bright blue light appeared, and the 7 physicists felt a wave of heat. Slotin promptly lifted one of the hemispheres and let it drop to the floor, ending the criticality event and preventing the core from self-destructing. Although Slotin reacted quickly to separate the hemispheres, he had already been exposed to a lethal dose of radiation. Slotin asked the physicists present in the room to mark their exact position in the room at the moment of the event. By establishing the exact position of each of the physicists in relation to the demon core, Slotin would be able to calculate how much radiation each of them was exposed to, and consequently, how much their lives were shortened. According to some physicists present in the room at the time of the event, the first words of Louis Slotin after realizing he had received a high dose of radiation were, "So that's it." Louis Slotin passed away 9 days after the accident due to acute radiation syndrome in the exact same hospital as Harry Daghlian and treated by the same team. The physicist Alvin Graves, who was closest to Slotin, also received a high dose of radiation and was hospitalized. He was left with chronic neurological sequelae and vision problems, but managed to survive the event. That's because Slotin's body served as a barrier. The other 6 physicists present in the room were also exposed to high doses of radiation, but not in lethal amounts. Some of them developed leukemia later on. Some of the physicists present did not live more than 30 years after the accident. It is estimated that in those few moments when the screwdriver slipped and the spheres closed, Louis Slotin was exposed to a dose of 1,000 rads of neutron radiation and 114 rads of gamma radiation. It's important to emphasize that it is estimated that the blue light, which appears after the core becomes supercritical, lasted only half a second until Slotin promptly separated the hemispheres. The blue light appears because radiation excites atoms in the air. These atoms release energy in the form of photons with blue wavelengths. After the accidents, the core that was previously called Rufus was officially named Demon Core. It was necessary to wait some time for the core to cool down and its radiation to decay. It was expected that the core would be used in nuclear tests, but the tests were canceled, and the core was melted down and the material reused to make other cores. It is invisible, imperceptible, and has no smell at all. The only way to know about its existence is through specific instruments that detect its presence. There are 3 different types of ionizing radiation that occur in criticality events. They are alpha, beta, and gamma radiation. Alpha radiation has the lowest energy level and consequently the least ability to penetrate and harm living organisms. It can be stopped by a simple A4 sheet of paper or by our skin. Beta radiation, which penetrates more than alpha radiation and can only be stopped by wood, metal plates, and other materials. And it is capable of causing burns and can penetrate about 2 centimeters into the human body, but without reaching any vital organs. However, the real danger lies in gamma radiation, which has high energy and consequently a strong ability to penetrate living tissue. It goes through practically everything and can only be effectively blocked by thick lead walls. Exposure to high doses of gamma radiation usually means a person doesn't have long to live, because it passes through and causes damage at the molecular level in the tissues of various vital organs, mainly causing cancer. But both Harry Daghlian and Louis Slotin would not be the only people to see the blue light.